All right, so let's go ahead and start on the next part of this unit. All right, we have been dealing with going from logs to exponentials and exponentials to logs. So now we're actually going to take and start expanding and condensing. But to be able to do that, we need to review the properties of exponents, which we dealt with back in the first unit. So let's go ahead and review those real quick. All right, so the properties of exponents. We have the same base of b, but it is being multiplied together. So anytime that it's being multiplied, if we have the same base, then we add our exponents. So we keep the base of b, and then we're going to have n plus m. Next, we have the one where we divide. Again, we have the same base, so we're going to keep that base. But when we divide our exponents, we subtract them. So b to the n minus m. Now remember, when we have a power raised to a power, then we're going to take and we're going to multiply those. So we keep our base of b, and it's going to be n times m. All right, so that's back at Unit 1. We've done those already. All right, but now we're going to take it and we're going to do it with logs. All right, and then we're going to do it with a natural log, which the natural log is the log base of e. So we're going to use this when we expand and condense. All right, so when we expand, we're making it bigger. So the rules are to look at what's happening. And right here it's being multiplied. So we're going to add that. So it's going to be log base b of m plus, and we're going to write log base b again for n. So we're going to take and we're going to separate them out, but they're going to have the same log base. Okay, so we're going to make it bigger. All right, when we divide, we subtract. So we're going to have log base b of m, and remember, the one on top always goes first, minus log base b of n. All right, now this one is one that we are dealing with an exponent. So this exponent right here is going to be moved to the front. So anytime that you are expanding, you're going to move that exponent to the front. So it's going to start out r, and then we're going to do the log base b, and m is by itself, so it's just going to be m. All right. Now, if you can recall, whenever we go left, right, left, pretend this is an x right here, okay? So if I take this and I write this out, and I have b to the x is equal to b, see if you can remember back. What power does something have to be raised to for it to be itself? Anything raised to the first power. So at this point right here, whenever you have log base of a number and the base and the number are the same, it's going to equal 1. So b to the first is equal to b. Anything raised to the first power is b. Now, same thing here. If I write that in exponential form, b to what power is equal to 1. Anything raised to what power is 1? And that one is 0. We talked about that yesterday. So remember, b to the 0 power is equal to 1. Okay? So if you look over here on this one, this little box that's given to you here, the properties remain the same even when you're working or dealing with a log base E or a natural log. As you can see, we have the log of E, or the natural log of A times B. These two are being multiplied, so I'm going to add them. But I'm going to put that same base for both of them. All right, these two right here are being subtracted or divided, so I'm going to subtract them. But again, I'm going to put the same log base with them. All right, this one is a power raised to a number raised to a power, so this is going to have to go out front, and then everything else will stay the same. Then this is log base E to the first. That is the 0, because this is just like saying log base E of 1 is equal to 0. Anything to the 0 power is 1. If we write that in exponential form, you'll see. All right, and then the last one, the log base E, or the natural log of E, is equal to 1. So log base E of E is equal to 1. Or if we write it in exponential form, E to the first is equal to E. Anything raised to the first power is itself. So that's your notes that you're going to have to be able to expand and condense, because you're going to have to know what it's saying that you're doing. So the next page says expand the following. We've got a log base 3 of x divided by y. Now expand, that means make bigger. So when you expand, you're going from small to big. All right, so if I look at this, I am dividing right here. So if you look back at your notes on the page before, when you divide, that means I'm going to subtract. All right? And I'm going to keep the same log base for both of those. So I'm going to have log base 3, because that's what is given to me. That's never going to change. And then the top is x, so the x is going to go first. The division, so this is going to go first. I am dividing, so I'm going to subtract. Let me make that all the same color. I'm going to subtract. And then I'm going to do the same log base again, so log base 3. And then my number on bottom is y. Now, when I'm writing these, then I'm going to want to make sure that this is a subscript, so it's a smaller number there, just so that way you know what you're looking at and it doesn't look like log 3x. That way you can tell that they're separate. All right, the next one. We're going to expand, and these two are being multiplied. Since they're being multiplied, I'm going to add them. And if you look back at the beginning of the notes, that's where that comes from. Again, I'm going to keep the same log base for both of them. So log base 3. Now, and I'm going to put this one first. So x, and then plus log base 3 of y. And that's my answer. All right, so all I'm doing is I'm using those rules, and I am making the equation that's given to me bigger. All right? Now, I have it raised to a power. This, if you can remember, will go out front of everything, okay? It goes out front of everything that it's with. So, it's going to end up being 2, and then I have the log base 3 of x. And that's as big as that one's going to get. That's expanding it. But since there's nothing else with it, I can't make it any bigger. All right. So let's go to the next one. All right, we've got a couple things going on here. So we're putting it all together now. We're putting more together. So if I look at this, on top, I'm multiplying. So if I'm multiplying, then when I expand it, I'm going to add. All right, I also have this going on, and it's being divided. So when I expand it and I make it bigger for this area, I'm going to subtract. Now, I have 3 parts going on here. So I'm going to have 3 log base 8s when I finish. Okay? But I'm always going to do what's on top first. So make a note of that. Always do what's on top first. All right, so if you have, and then you can put everything else on the bottom. Okay, everything on the bottom, you can put it last. So, and I will explain this as we get done with it. But if we look, we have log base 8. That's the first thing we're going to do. And it is 3. That's the first number we have on top. All right, 3x is being multiplied, so we're going to add that together. So log base 8 of 3 plus log base 8 of x. All right. Now, if I look at this right here, this is everything that was on top, so I multiplied it. Okay? Everything on top went together, and it went in front. And I keep the same log base. Okay? So always the same log base, no matter what. All right, now that's done with the top. So then we're dividing by y. So we're going to subtract log base 8 of y. And then if you look at this, this right here lets me know that I'm dividing everything that is in front of it, and everything in front of the subtraction sign is being divided by everything behind the subtraction sign. Okay? All right, one more with expanding, and then we're going to go to condensing. All right, so I have 2 things going on here. All right? Well, more than 2 things. But first of all, I noticed that it's a natural log, which is fine. We can leave it as a natural log. All right? Now, this is all being multiplied. So when I expand it, I'm going to add. Okay? Now, instead of using log E, since it's a natural log, we're going to write it with ln. But there's one other thing going on. We have x raised to the 5th and y raised to the 2nd. So we're going to put, if you remember, the rule for something raised to the power is to put that number out front of our log base. But you only put it what it goes with. But no, in the end, those are going to have to be up front. So our first one that we're dealing with is this one right here. The natural log of x to the 5th. So we're going to move that 5 out front. So 5, and then our base, ln of x. All right, that's the first one. Then the next one, we have y squared. So we're going to add, because it's being multiplied, we're going to add it. So plus 2 ln y. All right, and then we have one more. And if you look, z's not raised to a power, so we don't have to move anything. We're just going to have ln of z. And that's going to be my answer. Now, something that I want you to pay attention to, the reason the 5 is in front of the x is because x is all that is raised to the 5th. And then if you look at the y, y is all that is raised to the second. So the reason that it's only in front of that is because the only thing that's being raised is the x to the fifth. The reason the 2 is only in front of the ln and y is because y is all that's being raised. Okay? So watch over this a couple times if you need to. Once you finish, you can do some practice, and then you can go back once you've practiced and you feel comfortable with it. Go ahead and get your notes for condensing, which we'll just be doing the opposite. We'll go from big to small.